Okay, so we are going to be going over Lecture 3, Part 1. Lecture 3, Part 1 is going to be simplifying integer exponents. We're going to be talking about our rules for exponents, and then we are also going to be applying those rules of exponents to simplify algebraic expressions. All of this stuff should be reviewed from last year, but we are going to get some additional practice in here, try and make sure we got this stuff solid, know what we're doing. Should be 3 videos for this one. First one is just going to be on simplifying our integer exponents. So starting out, we have a to the nth power. So what does the a to the nth power mean? Well, a to the nth power means that I've got a times a times a and so on and so on and so on. Okay, and I've got n equal factors of that. Okay, so we write that as an a to the n power. That n is the power. It is our exponent. Okay, this a here, our a value there, that is our base. A is our base. Okay, this should be reviewed for you guys, but just making sure that we've got everything. If I have 3 to the 4th power, that means that I have 3 times 3 times 3 times 3. Okay, 4 there tells me that I need 4 3s. Okay, hopefully that is review for everybody on our exponents, what they mean. Okay, we're going to go ahead and go on then. Common mistake, something that we need to pay attention to when we are dealing with our exponents, has to deal with parentheses. If I have a negative 2 to the 4th power, that is different than a negative 2 to the 4th power. Okay, so I want you guys to hear me say that again because the parentheses matter. A negative 2 to the 4th power is different than a negative 2 to the 4th power. Okay? If I have a negative 2 to the 4th power, that is 4 negative 2's all being multiplied together. Okay? Negative 2 gives me 4. Negative 2 gives me 4. Positive 4 times positive 4 gives me 16. Versus when I have a negative 2 to the 4th power, that is really a negative 2 to the 4th power. Okay? Because order of operations, I'm talking PEMDAS, says that I do exponents before I deal with multiplication. So I've got to deal with this exponent here first. So this is really a negative 2 times 2 times 2 times 2. So it's really a negative 16. Okay, so especially when you guys are plugging these things into your calculator, you have to pay attention to those negatives. All right, so I said we were going to talk about integer exponents, and you guys by now should remember your integer exponents would be like negative 2, negative 1, 0, 1, 2, 3, 4. Last slide, we covered how to handle all of those. Okay, so this slide here we're going to be talking about what do negative exponents mean for us. Okay, well, if I have an a to the negative n power, that is going to equal a 1 over a to the n power. So what you guys should notice is this a to the negative n, that's like it's on the top of the fraction. And then it all of a sudden ended up on the bottom of the fraction. So what we need to know is when I have negative exponents, you're going to switch what side of the fraction they are on. So since that a to the negative n was on top, that is going to move it down to the bottom. Okay? Also notice that the exponent is now positive. Okay? So if I have an x to the negative 2 power, that's really over 1. And that is going to move that down to the bottom. It's going to become a 1 over x squared. Okay? So it moves to the bottom and it makes that exponent positive. Got a couple examples down below that we can look at. 13 to the negative 4th power. Okay, if I'm doing 13 to the negative 4, it's over 1. That negative means that I need to move it to the bottom. So that becomes a 1 over 13 to the 4th power. And then we can figure out what 13 to the 4th power is. And I don't want to do that. Okay. Next, I've got a negative 2 to the negative 3rd power. Okay. Notice, just like we talked on that last slide, that negative 2 is in the parentheses. Okay. So that is included. This whole thing is going to move down to the bottom. So that's going to become a 1 over. It is still a negative 2. It's only the exponent that became positive. Only the exponent became positive. Still a negative 2. Okay? And then obviously the other example would be is if you had a 1 over 4 to the negative 2. We have a negative exponent, but it's already on the bottom. That's fine. That just means we need to move it to the top. So this becomes a 4 squared over 1, which is just a 4 squared. I don't really need to write it over 1, which would be 16. Okay? So, negative exponents, it switches what side of the fraction bar it's on. Okay? Positive, we've been dealing with those forever. Okay? Negative, we introduced those last year. I think you probably did them as freshmen too. It just switches what side of the fraction bar it's on. Then the only other thing that we've got to cover is this guy right here, 0. So what does it mean when we have a 0 exponent? Well, we're going to look at some examples here because there's a pattern that you guys are going to find with your exponents. Okay? 2 squared. Hopefully everybody here remembers 2 squared is 4. 2 cubed, another fairly common one. 2 cubed is 8. 2 to the 4th, 16. 2 to the 5th, 32. 2 to the first power, remember something to the first power, it's just itself. So that gives us a 2. 2 to the 0 power. Not sure what that equals. We do know, though, that 2 to the negative 1, that means that that moves it to the bottom because, or so, that becomes a 1 over 2 to the first power, which 1 over 2 to the first power would just be 2. So it becomes a 1/2. 2 to the negative 2, that moves to the bottom, so that becomes a 1 over 2 squared. Well, 1 over 2 squared, 2 squared is just 4, so it's 1/4. Okay, so this is our pattern. This is what we've had. So what does it mean when we have something to the 0 power? Pause the video, see if you guys can figure out what the pattern is between these numbers. Okay, hopefully you guys have noticed these are moving by 2. If I take 32 divided by 2, it gives me 16. I'm halving them, right? And that pattern continues all the way down. So if dividing by 2 is happening on everything, we could probably make a hypothesis that that pattern should continue, right? So what is 2 divided by 2? Well, 2 divided by 2 gives me 1. So we're guessing that 2 to the 0 power gives us 1. Does that pattern continue? What's 1 divided by 2? Well, 1 divided by 2 gives me 2. 1/2 divided by 2 would give me 1/4. Okay? So we found that 2 to the 0 power equals 1. And you guys can perform this same experiment with 3 to the 4th power, 3 to the 3rd power, 3 squared. And this pattern will be true. So our statement that we can make on this is anything to the 0 power is 1. Okay? So here, I'll write that as a statement. Anything to the 0 power is 1. Okay? So that's our rule. A to the 0 power equals 1. There is one exception, and this has shown up on a college algebra test. That's the only reason why I'm showing it for you guys. One exception would be 0 to the 0 power. Okay? 0 to the 0 power is undefined. Dividing by 0 is undefined. 0 to the 0 power is undefined. Okay? There is one more little rule I want to talk to you guys about here, and that would be negative numbers with even powers and negative numbers with odd powers. Okay, if I have a negative 1 squared, that's just a negative 1 times a negative 1. Two negatives make a positive, right? Versus if I have a negative 1 cubed, negative 1 times negative 1 times negative 1. Well, these two together, two negatives make it a positive, right? So now you've got a positive 1 times a negative 1, which positive 1 times negative 1 gives me a negative 1. Okay? Well, let's keep going. If I have a negative 1 to the 4th power, there's 4 negative 1s, right? Okay? These two come together to give me a positive 1. These two come together to give me a positive 1. What's positive 1 times positive 1? Well, that's positive. If I did negative 1 to the 5th, sorry, negative 1, negative 1, negative 1, negative 1, negative 1, positive 1, positive 1, negative 1. Okay, well, those two positives would make a positive, right? But I always still have that one negative hanging over. So basically what you should see is when you've got here, we've got even exponents. Our even exponents, the negatives end up canceling each other. We end up with a positive number, right? Versus my odd ones, I've always got one guy that's left over that ends up turning it back to a negative. Okay? So that provides us with a rule here. That provides us with a rule. And our rule is, and this will help you guys periodically throughout the year, the rule is that if you have a negative 1 to the even power, so basically anytime you have a negative in parentheses and it's to an even power, you're going to have a positive answer. Versus anytime you have a negative and there is an odd power, it will always stay negative. Okay? This kind of applies. We did this last year, and I would say we've got a negative number here. Is it an even power? Yes, the even kills the negative and it becomes positive. Okay? Odd power, the negative is spared. It stays. Okay? So, somebody asks you what's negative 1 to the 1,226 power. Well, that's an even number, so it's just a positive 1. It's definitely going to be positive. Negative 1 to the 213 power. That's an odd one, so it's going to stay negative, and it's just a bunch of ones together. Okay, so that's just kind of something, just a little fact that kind of periodically will help you throughout the year just doing some of your mental math.